All right. Hi, everyone. Welcome to the Targets workshop. How's everyone doing?
Great.
Cool. Yeah, maybe we'll give another minute or so to see if anyone else trickles in. I think it's going to be a small group today, which is actually pretty great. I'm used to doing workshops with a bigger group, and I think especially virtually, I think this will be a good chance to interact a little bit more and kind of tailor it to everyone's experience. Cool. Got a few more people trickling in. Was everyone able to get signed into RStudio Cloud and able to start the assignment to access the material?
I'm able to access it. I didn't really start anything.
Okay, perfect. That's if you went through it already, then it'd be no point in being here. So that's perfect. I guess maybe I should say, is there anyone who's had trouble accessing it? Cool. I will take that as a good sign then. I think we're just about at the number that signed up, so I'm going to go ahead and get started. Let me share my screen. Cool. Can everyone see my screen all right?
Yes, I see a screen.
Yeah.
Yeah, so welcome to Targets package. This is really exciting. This is a package that I enjoy using a lot. And so I'm excited to kind of share what I've learned about it. And yeah, it's a really cool package. So a quick overview of the agenda for the day. This is kind of a rough thing of what I'm kind of aiming to do. Spend about 10 minutes. Welcome, kind of overview of what we're going to do today. We're going to spend a little bit of time on functional programming, just kind of quick refresher on like what functions are, how to define them. But the main purpose of that is really going to be talking about function-oriented workflows, which might be a little bit different than what you're doing in your day-to-day work. And then we're going to spend a good chunk of time kind of going over what a pipeline is, a target pipeline. Take a quick break, and then we'll cover last couple of topics that we'll cover are debugging and Markdown. And then whatever time we've got at the end will be for closing thoughts, questions, kind of give like a preview of some more advanced topics. So quick introduction on who I am. So my name is Mike. My background is in biostatistics, UW, did clinical trials research, went to Fred Hutch for about 5 years, was a statistical research associate doing cancer screening and surveillance. And then the last couple of years I've been with ProCogia. We're a consultant company based out of Bellevue and Vancouver, BC. So I've worked in a variety of industries there with clients in telecom, nonprofit, finance. So kind of moving on to the content here, kind of like motivating why we care about like what is the targets package and why do we care about it. Like there's kind of two main reasons. One is reproducibility, and I kind of want to touch on some terminology that can be confusing sometimes: reproducibility versus replicability. So I like this quote that just says, replication is independent people going out there and collecting new data. reproducibility is independent people analyzing the same data. So both are important. The targets package is really focused on the latter. It's saying, how can you repeat your, say everything crashes, how do you, given the same inputs, the same data set, how do you regenerate that exactly? Because, if you're analyzing the same data, with the same code, the same methods, you should get the same answer. And then of course your replication is an entirely important but entirely separate question. So there's a bunch of available tools that are out there, and I think particularly with our user, you might not have a software engineering programming background, so you kind of have all these different things that kind of work on different aspects of reproducibility, and it can be confusing trying to figuring out which ones you should use, how they work together. Do you pick one over the other? So some that you might have heard about, Docker is a tool for reproducing your computational environment. If I run code on my laptop and you run it on your desktop and then it ultimately gets run on a server somewhere, how do we guarantee that that's all going to run the same way? That's what that addresses. There's Git, which is version control that's used to keep track of your code, make sure that you can, people are working off the same versions of code, helps with collaboration a lot. There's virtual environments like renv, helps you keep track of like package versions and environments specific to the language you're working with. And then there's this other one, just one that we're covering today, targets, and that's reproducibility of your workflow. And so you probably sit down, often you might open up some different scripts, you write different functions, close things up, and then maybe you try to reproduce that, a day later, a week later, a year later. And what if you run things in a different way? Your versions have changed. Targets kind of tries to solidify and make your actual workflow, how you do your analysis, reproducible. So it's not a replacement for any of these. It plays nicely with the above. If you're maybe just getting started, newer R user, you're like maybe newer to programming and all of this is like really overwhelming, you don't need to incorporate all of these at once. Not all, sometimes, for simple projects, they might not be appropriate or necessary to use all of these different tools. But yeah, so it's standalone, but it works with these other tools. So a bit about the package. Written by Sky Will Lando, Eli Lilly, part of the R OpenSci framework, which if you're not familiar with, highly recommend checking that out. They've got a lot of great packages, a lot of really cool stuff that they're doing. It's a pipeline tool for statistics and data science in R. It's inspired by GNU Make, which if you don't know what that is, don't worry about it. If you've heard of it, it's basically just specifies steps in some computation that should happen. And then you run kind of this top level command and it executes those steps exactly how you specify it. So there's a similar package by the same author actually called Drake that has done this for a while, and I think they kind of learned a lot of lessons of what worked and didn't work and revamped it, and that's what became the targets package. So again, it enhances the reproducibility, specifies exactly how the analysis should be run, and allows you to reproduce the entire workflow with one command. So I'm selling this on, reproducibility, but there's another huge gain by it, and that's efficiency. Sometimes if you're running, a model or some code, it might take, hours or, even days to run. And, sometimes you go back and you're like, oh, like I need to change one little thing, but maybe that little thing that you change only affects part of your code and you don't want to rerun earlier steps. Maybe you don't want to rerun, you import your data, you do a bunch of wrangling, you model it, and then you want to change something in your report. You don't want to go back and do all of the earlier steps. You don't want to read in the data again. You don't want to run the model again. So, targets keeps track of downstream dependencies. So if it's only going to rerun things that need to be rerun. Yeah, so learning targets, it's got a little bit of a learning curve, and the user manual is really great. And then I'm also going to point out this workshop from the author. So you might wonder like why I'm pointing out a workshop when that's why you're here. Those are authoritative, comprehensive, but it's definitely a little bit dense. So like that workshop uses Keras, and you're fitting, using tidy models and fitting models, tuning, creating training test splits, doing all this complicated stuff where it's like maybe you're doing that and that's great, but sometimes I found it a little bit challenging to like get into it and just learn the bare bones. So that's my goal with this workshop, is just to provide like, here's like a really simple, kind of toy analysis that we're going to work with. And I'm going to show you the core functionality with it and hopefully give you an idea like, this is what it does. Here's how to do the basics. And that'll be a good jumping off point for you to, go on and further your knowledge. Because there's definitely, it's complicated enough that, 2-hour workshop isn't going to give you everything that you need to know. So yeah, credit, I've definitely borrowed and adapted heavily from those workshops. So consider this kind of like an intro to that workshop and the manual. Yeah, so let's go ahead and get started. So if you open up the, click start assignment, you should open this up and get your own RStudio environment here. I'll also note that, that we're doing this in RStudio. There's a lot of things that have been built into the targets package that make it easy to use RStudio, but it's not necessary to do it. You can do it, from whatever editor, whether you use like the base GUI editor, whether you use something like, I'm not sure, presumably it would work in like Vim or Visual Studio, but there are definitely a couple of things that make it a bit easier to do in RStudio. So let's go ahead and start with, so yeah, I'll kind of give you an overview of the structure here. There's a bunch of R Markdown documents that we're going to work through. So 1, 2, 3, and 4. The necessary data and some ancillary code is in these other folders. You don't really need to think about those right now, but if you go back later and dive in, then data and stuff are located in those folders. So let's start with this one, functions. Hopefully, so I've copied your space from mine. Hopefully it should be, I think I cleared all the output, but you might want to just click the little cog there and hit clear all output just to make sure. And you can hit the little, if you hover on a code chunk here, hit the little green arrow, that'll run just that chunk. So we're going to use the tidyverse for our analysis, and also specify, if you're, say, newer to R, or say you use base R, not tidyverse, understanding the code isn't actually really terribly crucial to understanding the targets package. I'll kind of go over what it does. If you don't understand the exact specifics, or you're unfamiliar with one particular function or option, it's totally fine. It's more important to understand the larger steps, like we're reading in data, we're wrangling it, we're making a plot. So yeah, quick introduction, kind of refresher on functions. So this is definitely pretty basic, but I just want to refresh. Functions they're central to our programming. You can define, they take an input and they give an output. So here's a really simple function that just takes 2 numbers, adds them together and returns it. Obviously, this is going to cause some issues if I try to pass this, character variables, or things of different, not things that you can't, obviously you can't add together, but as an example, right? So it's we specify inputs, curly brackets, assign it to an object, and then return. So here's it works great. So what we're going to do is, instead, often your workflow might have a bunch of the redundant code, or separate scripts that's you have like one that's maybe reading in the data and creating some new variables. You have another one that's running a model. You have another one that's creating plots, and then kind of end up either organizing those at some like top level script and sourcing them all, or just kind of going through and running each one in sequence. And that works all right, but it doesn't really scale for a complex project. And the first step to reorganizing that kind of code is to use a function-based approach, so a function-oriented workflow. So I'll show you what I mean by that, just kind of going through an example here, and we'll continue using this one example throughout the workshop. So we're going to use the penguins data from the Palmer penguins package. If you haven't seen this before, it's kind of very similar to the iris data set, which maybe you're probably much more likely to have seen. Just a really good data set for showing kind of basic clustering, doing simple analyses for demonstration. And we're going to go through, we're going to do apply a few steps. We're going to read in the data, and then we're going to clean it. We're going to apply principal components analysis. We're going to perform k-means clustering, and we're going to generate a plot. So again, if you don't know exactly what principal components is or what k-means is, it's totally fine. Just, this is going to transform our data in some way. This is, a statistical algorithm that we can apply, and then we're going to show a plot. So first thing we're going to do is read in the penguins data. And we're going to use the glimpse function just to get a sense of what it looks like. Should also just mention here that, since we've got such a small group, if anyone has any questions or wants to, is having trouble with something, feel free to jump in and interrupt. That's, totally fine. We can be a little bit more informal with this size group. But cool. So we see we've got 275 rows and 8 columns. Here they are. We've got measurements on species, what island they came from, some body measurements, build, length and depth, flipper length, body mass, sex, and the year that the data is collected. So we're gonna do a little pre-processing. So we've got, so here we've got the first function. And that's, we're just gonna call it clean data, and it's gonna take raw data and just do a bunch of transformations on it. So I'm selecting the variables that we're going to analyze. I'm just going to drop all missing for the sake of the analysis. Obviously not always a good idea in practice. And with principal components analysis, you want to scale your measurements, to center them so they've got mean 0 and standard deviation 1. So notice that, like, say we had new data and we needed to clean it. Instead of having to copy and paste this and say, okay, like data 1, data 2, and doing the same thing over and over again, we can just apply that one function to the data. And, that helps, if we find an error in our code, or we decide that we want to, change that cleaning script a bit, you just change it in the function, and then you don't have to worry about it. And then, those changes will carry on to, every time you apply it. So we run that, and we got our data. It looks like this. I'm going to generate another function to run principal components analysis. And again, instead of just doing all of this on, say, like data set 1 and then having to copy and paste it and run it on, data set 2, I'm just going to put it in a function, and it just takes an argument that's, a clean data set, and run components analysis on it, do a little, I'm going to add in what species in addition to, the components, and return it as a tibble or a tidyverse version of a data frame. So great. Yeah, we've got 4 components. Our species here, our analysis is going great. One last step, we're going to run k-means. So this is just a clustering algorithm. Writing this function as, you take in the data, which I'm assuming is in principal components, has principal components applied to it, and then number of clusters that I'm going to look for. So this is kind of, a bit of a silly analysis. I know that there's 3 species, so I'm just going to run it with k equals 3 and see how well it does. So here's my output, predicted cluster, species. So hopefully, these clusters line up decently with the species, and we can check how that worked by another plotting function, which is just going to essentially create a like a confusion matrix or heat map type plot where we've got cluster and species. So you can see, not surprisingly, it's kind of a simple toy analysis. That didn't work too great. but we're able to, there's some separation in there. It's not total chaos. But I'm sure if we were actually just clustering, we could do a lot better than this here. But in summary, we've got the framework for our analysis, and we've put each step into a function. So we've got a function that cleans our data. We've got a function that transforms it, does some feature engineering. We've got a function that runs our algorithm, and we've got a function to plot our results. Are there any questions there? Cool. So I'm going to move on to pipelines. So the second notebook. I'm also just going to restart R, just to clear everything up, clear out my environment, just to make sure that there's nothing lingering from that first module. So here we've got just the summary of the steps that we did in that simple analysis. And in this module, we're going to turn that into a targets pipeline. And I'm going to show you the kind of the meat of what a project requires, or what targets requires a project to have. So I did all of that. I defined the function, then ran it, defined a function, and ran it. So it's kind of a little bit scattered, but here's an example of how that analysis essentially looked. So I loaded in the libraries that were needed at the top. The better practice, instead of mixing in those functions within the code that they're being called from, would be just to put them in their own file. So I've done that. I put those in this functions.r file, and then I can just do the analysis like this. I'm going to read in the data, clean it, and then I'm going to run the PCA, and notice that each function is being called on the previous object that's defined. So these steps are what's referred to as a target in the target package. So think of a target as some unit or step of your analysis that's being done. So that could be, in kind of simple analysis, it could be something like this. You can also just track files, track objects. Any bit of our code is a target, or can be a target, and it's up to you to figure out exactly how to do that. One option would be to put your entire analysis into one massive function and then run that as a single target. Of course, that's not taking any advantage. It's going to be reproducible, but it's going to probably be really complicated, really messy. Everything's going to get run every time you do it. So it's really kind of a trade-off of figuring out, the more fine-grained you make your functions, the more targets you're going to have, and you're going to have complexity that way. So it's a kind of a balance of, separating it enough, but still making it understandable. So all of this is within targets. Your entire analysis, there's kind of a control center that's this targets.r file. And this is a special file that lives at the root folder of your project. So if you're using like RStudio projects, let's see. Oh yeah, I just got a question about talking about the source helper function. So yeah, we can actually just do this. So I've got functions.r, which is starting out just empty. And I'm just going to do kind of most basic script you can think of, just add two things together. So I've saved that. I've got, this really, really basic R script that just adds 2 + 2. And there's a few different ways to execute R code. So I could write that, just type it in here, right? Get 4. I could run it from here, but maybe I want to call this from somewhere else. Call this from another, another R script. So a way that I can do that is via the source function, and basically that'll just point at whatever file path you give it, whatever R file path to an R script, and it'll just run that code with from the script. I'm going to make a new code chunk here. Do that and just run this.
Missing a parenthesis.
Oh, yep. Perfect. Thank you. Cool. And that ran. So you'll notice it actually didn't put anything to the console because I didn't tell it to do that. Okay, now I'm telling it to print, and you can see I'm calling that from a totally separate area. So we're going to use that mainly in this workshop to put our functions in a different place, so that instead of having to define them in each script, we can just have them in one spot and just like source them in, and then they're available. And as for a more complex project, you might have a lot more functions as well that really makes sense. Then it makes sense to fit into one folder. So you might want to break them up. Maybe you've got a bunch of different modeling functions, or your cleaning processes, got 50 functions in or something like that because you're working with really messy, complicated data. Then you might want to have like r/cleaning functions.r, and then another one for modeling and so forth. But for this case, we'll just put them all in one folder, one script, functions.r. Cool. So the way that this workshop's going to go is I've got all of the these functions and the templates for the targets package within these folders, 2.pipelines and 3 debugging, etc. And just using the file.copy functionality to copy those over into our current working session. So you don't really need to think about this too much, but if you just run it, this is going to move those over into our project root, and then we don't have to worry about like manually moving those over and making sure that everyone gets that copied over. So if it says true, true, that means that both of them are copied over just fine. Our next step is going to be, we're going to load the targets library. This is unnecessary now, but going on, we're going to want to destroy, every time we're starting out with a new example, we're going to want to destroy anything that's lingering from a previous one. This is dangerous to run in practice on a real project because it is going to destroy all of the cache, everything that's been saved from previous runs. And it's essentially starting out from scratch. In the sense that, your targets file, your recipe for generating the analysis will still be there. You'll have to run every single step over again. So let's run that. There's a useful function called tar edit, and all that does is just open up the targets file in your working directories. That's kind of useful. And then the use this package has an edit file. We're just going to use that to open up the functions.r. You could easily do just the same thing, clicking over here in your file explorer. Cool. So if we do this, we now see we've got our 2 packages, functions.r. These are just the functions that we've already defined. Nothing's changed there. And spend a little bit of time talking about the targets.r, because like I said, this is really the command center for the analysis. There's a handful of things that have to be specified. First is library targets. Second is pulling in all of the functions that you want, that that define your targets, define the steps of your analysis. So that's where, and I think this is the only time we'll use that source function, but that's where we bring that in. So we're, instead of copying, pasting all of these in here, which would also work, it's just a lot cleaner to keep those separate. You set your options for the workflow. We're going to talk a little bit more about other ones, but for right now, what you do is you just specify the packages that you want. So you'll notice that I'm not saying library tidyverse up here. And that's because when I actually kick off this workflow, it does it in an entirely clean, fresh R session, not the one that we're working from. So it's not going to help if we attach the packer, load the library in here. It needs it in this isolated process that it's doing the entire analysis in. Of course, if you add more packages, you could just add them in there like that. And then the targets file should end with an unnamed list of a bunch of your targets. And the targets, so you use this tar target function to define it. The first argument is just a name. So it's not quoted, but this is just any custom name that you want to give it. And this is how you'll refer to the targets later. You give it a command. So in this case, it's a file path, and we need to tell it that it's a file. That just keeps track of our raw data. So, if our data changes, and this could be, you go in, edit it, change like one entry in that CSV file, and then targets would pick up on that change and would run everything downstream. And then if it's not a file, it's essentially you specify the name and then just an R command. So right now I'm just saying that I want to apply the read CSV to this previous target raw file. So I'm reading, so I'm tracking the raw file, I'm reading it in. I'm going to make a new one that's just clean, or next target's just going to be clean. And I'm going to apply that clean data function to the raw data target. And then I'm going to run PCA or create another target called PCA. And I'm just going to call my function run PCA on the clean data. And you specify your list of targets like that. So there's a few ways, for something small like this, you can kind of figure out what's going on just by reading the targets file. But there's some built-in functions that really help you visualize what's going on, because it's not uncommon for a project to have dozens or even like hundreds or thousands of targets. And in those cases, you wouldn't build them up manually like I just did, but there's still ways to do that kind of automatically and programmatically. And then of course it becomes just a mess trying to understand what's really going on. So the most simple one is just tar manifest. And this is basically just like a data frame representation of those targets. So it's telling you what the name is, what command is being run. This pattern is for a more advanced topic called branching that we won't get into. There's the glimpse function. So this relies on the Viz network package, which is like a network analysis kind of package. This actually is like an interactive graph that shows all of the targets and how they're related. So this one's pretty simple. You can see that got raw file, and raw data depends on that. Clean depends on raw data, and PCA depends on clean. And since if you're using two fingers, by the way, to scroll, or wheel on a mouse system to scroll in and out, it's going to try to zoom in on that plot. So just move over to the side to scroll down. And my favorite one, I think the most useful one, but it does take a bit longer to run for a larger pipeline, is Tarviz Network. It's pretty similar to Glimpse, but it also shows the functions that are in there, and it shows the status. So you can kind of take a quick look at what's going on in your pipeline, like how everything is arranged. You can see if you've forgotten to connect a couple of targets or something that's kind of isolated out there. And it also gives you the status. So right now we haven't run the pipeline, so everything is outdated. We'll see how that changes once we finally run it. So yeah, you'll notice right here, I haven't done anything. I haven't run k-means. I haven't plotted yet. So those functions are there. It's tracking them. It knows about them because we sourced them from the functions, but it's not connected to our pipeline. So if we were to go and change one of these, none of the actually computational intensive parts of our pipeline would get rerun. So finally, we want tar make is what will actually run the entire pipeline. So you can see we get some output from our read CSV. It's telling it that it's reading it in. And along the way, it's giving us some progress here. It's saying that it's starting tracking the file, then it builds that target, starts the next target, that's reading it in. Okay, it's built that, and so on, and then finally, the pipeline is ended. So now if we visualize what's happened, everything looks pretty much the same except for the colors have changed. So now it says up to date. So this means that everything is done. If we go, run tar make again, I'll just do it down here in the console. Instead of building all of those, it's skipping all of them because it says, well, it already did it. There's no need to do it. And it's really fast. So if these different points say like took an hour to run or something, and then you're getting stuck and you're trying to work out a bug in your modeling script or something, you don't have to do those earlier steps all over again. So it's run, but this might feel a little bit anticlimactic because you're used to like having the results right there. You've got them in your environment, or you output to a CSV or a report or something, and you can actually look at it. So here it's kind of like I told you, it's all kind of nebulous behind the hood, ran it in this isolated process. It says that it did it, but how do you actually get your hands on on your results? So under the hood, there's this underscore targets folder that gets created, and within there's an objects. So you can see I've got these different objects here corresponding to the different targets, and those are basically the output of each of those steps. And they're binary files, so if you try to open them, you're going to get an error, or if you maybe at best you'll just get a window full of gibberish. So you read them in with these helper functions, tar read and tar load. So for example, like the clean data set, we hit tar read, we just get that table that we created. And there are different ways of storing this if you're working with like really large data sets, or efficiency of read and write is really important. You can use the FST package. If you use data table, there's a special format for loading data tables in and out. But just by default, we can just read back in the table that we created. So now that these are created, in other, say like scripts or reports outside of the pipeline, you can access those objects that are created, and they're all stored in a convenient spot with the name that you created for them. Tar load is something specifically used for files. So if I run tar load on that raw file, it just gives me the file path of the raw file. Cool. So let's go ahead and do a first exercise, kind of keep this a bit interactive. If you open up that targets file again, your first exercise is just to complete the pipeline. Remember I said we've got that k-means and the plotting function that haven't been run yet. So go ahead, open this up, and add those targets there. I'll give you a few minutes to work on that. If you need a hint, you can scroll back up to the top of the notebook where I did that. I showed you how each function should be called. So once you've done that, it's totally fine if you're still working on that. There's another function that's useful called tar outdated. And if I run that right now, it just doesn't return anything because my pipeline's up to date. But once you make those changes, try running that in the console, or even if you just add one target, run it in the console and see what happens. Like this is a good way of, if you're working on something you're not sure, like before, right now we can pretty safely just run tar make because the whole pipeline takes 10 seconds to run. But if this is a pipeline, maybe you're working on something and you want to make sure that you're not, kicking off, a 10-hour job or something. So you can check and see which things are outdated, decide whether or not you want to rerun it. Cool. How's everyone doing? Any successes or errors or?
I got an error running trying to get the k-means model. But
Cool. I can run through it here on my end, compare and see what's going on. So anytime you're adding a new target, what you'll do is just add in, specify tar target. And it's going to take those two options. So you can give it whatever name you want. I'll call it k-means. And then here, if it's not a file, you're giving it essentially any R function with, kind of follow this pattern, like some R function, and then the argument is going to be a previous target name. So that's something to keep in mind too when you're designing your functions. It should take in the input to your function should be another, the output of a different target. So in this case, our function is going to be run km, and we're going to run that on the PCA target. Which if we go, back up here, so we run PCA, which is the last thing that I had in the template, and then apply the run km function to the output of the run PCA. So save that file, do run tar outdated. Now it's saying, okay, the KM target is outdated. And if we do Tarviz Network, I'm doing this in my console, so it's going to pop up over here. Let's see. Everything else is still up to date, but now I've got this new target that's dependent on here, and it's currently outdated.
Yeah, I have a question about this diagram. So I found my error. I needed to pass in k equals. Oh, you didn't pass in a parameter.
Oh, yep. No, that's
when I passed in k, a value for k, then I got then it worked fine. If I didn't pass in a value for k, I got a funny error. But my question actually is about the dependency. I expected clean data, the raw data, and then the transition to clean. I don't understand, how do you get the transition from raw file to raw data? Isn't that passing through the clean data function? Or
kind of seems like the same thing, right? So this is,
sorry,
I was gonna say, maybe my confusion when I started working with this was it almost feels like you're working with the raw data twice. But really there's two separate things being tracked here. The one is like the raw file that's on your file system. And then the other is that representation once you've imported it into R. So you can kind of think of it as the CSV and the data frame. So raw file is actually just tracking that file path. And anytime the contents of that file path changes, it'll flag it as being outdated.
Yeah.
The raw data is just pulling in that file path.
So the read CSV doesn't show up in our list of functions in the diagram because that's not a function we defined.
Exactly. Yep.
It's an external function somewhere.
Exactly. Yeah. And within targets that are, I'm calling it, on read CSV here. I could do, I could even say I just wanted to like call in the first, first few rows or something like that. I could do that. And yeah, you're right. Like head is not going to show up there either because any R command can be put in here. And it's not going to show up as a function.
If we wanted to be more explicit, we could define our own load data function, which just calls read CSV, and then load data would show up in the dependency graph.
Yep, exactly. And for a larger project, that might be a better approach too, because then you can do things like specify the schema, know whether or not you want to read in all of the columns, different options. For this case, I'm just calling it all in at once. But yeah, and to answer your earlier question too about why you're getting an error there, if I'm not getting an error because I haven't tried running it yet, and yeah, you're right, you would need to specify because I didn't put a default in. The other option would be changing this function to setting a default.
Are those parameters like k = 3? Is that represented somehow in the state of this? So like if I go back and update targets to k = 4, will I see that something's undead? I mean, I can try it, but I haven't yet.
No, that's actually a really good question. Let's run that, and everything is up to date now. And let's change that to 4, save it. So kind of doing the comparison, here's before, where it was up to date. And then as soon as I change that to 4, or what was 3 up to date, when I change it to 4, it detects that there was a change in that command. So it's not only tracking the your targets themselves and the functions that you've pulled in, but actually the command itself. So anytime anything here changes, it's doing that. It's tracking that as well. Any other questions or?
Are there best practices as to where you should be putting hyperparameters like that?
Yeah, I think there are. And I think it's wildly dependent on exactly what you're doing and the context of the project. And I think, like I said, even just in deciding how many functions to make and what they do, there's a trade-off of like, if you don't make enough, then you're gonna have to rerun a lot of code over and over again every time you run the pipeline. But if you break it up too much, then it gets to be unwieldy and complex. So I think it's a little bit of an art, just like finding that balance. And same things with the hyperparameters too. Like this is probably not, and this kind of gets into a more advanced topic called branching. But say like I wanted to run it on a bunch of different options of K. I could do that in a way that doesn't involve copying and pasting this and putting in different values. But again, like I said, that's kind of the next step, or that's covered in the full workshop from the author.
One more question.
So in general, yeah, there would be better practices than just specifying it there.
One more question. In the diagram, it mentions stem for a circle. Is that like another word for an artifact, an output of the function? What's a stem?
Yep, exactly. It's the stem is basically a stem within the plot. It's the target itself, and it's differentiating that from a function.
Okay.
So you basically, you get a stem for each target that you specify. So here we've got 1, 2, 3, 4, 5. There should be 1, 2, 3, 4, 5 there, along with the 3 functions that are incorporated, and then the additional one that hasn't been brought in yet. Cool. How's everyone doing energy level wise? I put in some time for a break, but we can keep going, or I think this is definitely the bulk of like the longest session. So the rest of it's going to be, should be a little bit quicker, a little bit, just work playing around with this framework basically. But happy to, if we want to take a 5-10 minute break, or people want to keep charging through.
I'm good to keep going, but either way.
Cool. Let's just keep blasting through then. So let's go on to the debugging file. And I'm going to do that same thing again, just restart our figure out my environment. Now in this case, so before I said tar destroy is important because it within the context of the workshop, because it's going to get rid of everything that we've already done. Right now, if I run, I guess I've restarted my session. If I load targets again, Tarviz Network, you can see I've still got it's run. Everything is at the state that I left it before, which is not usually that's what you want. But in this case, it's not. We want to start out from scratch. So you look in targets, we've got those different objects that are there. If we run this, that's basically just going to destroy everything in the cache. So it's still, our targets file is still going to be there. So we could run tar make again and build all of that right back up again. But it's going to, it essentially deletes your cache. So now we're going to move over or copy over the, created some more a different set of functions and different targets file. We're going to copy those over. Also, I'm not sure why I've been getting this error just in RStudio Cloud, something with creating the notebook. So if you're seeing it, it hasn't caused an issue for me. So I've just been ignoring it. It wasn't coming up locally. Something I think it might have to do with Pandoc, but cool. So basically I've introduced a bug into the code. And so if you try to run it, everything goes great and it crashes. And I think, if you spent much time at all with R, I'm sure you've done some debugging. And of course that's, can already be a frustrating process where you're trying to track down, enter an active debugger, set, breakpoints, or entering using browser, all of these different techniques that you may have picked up. And that's can be frustrating when you're actually doing this in an interactive environment. You can kind of step into the code at each point, bounce around between the script and the, bounce it around, in between the script and the console. But now everything's kind of behind this layer of abstraction. Like I said, it's kicked off in this isolated environment, and you might be thinking okay, where do I even start to debug? So one option, of course, is just go back, reread your code and try to figure out what's going on. But that's probably not going to, that might not be very helpful. Or if you don't find your error right away, what do you do next? So we can look at our status of our network, and we've got, now we've got another color. So it ran everything fine up to KM and gives us a flag that errored. And then you'll see plot is still outdated because that depends, everything downstream of the error didn't get run. So this gives us some information, we know exactly how this target was created, what function was used to do that. So that gives us a starting point to look for. And then, but even with that, maybe that function that you created calls other helper functions that you've put somewhere else. And the example I've given you is I hope fairly straightforward to figure out, but you want to be able to use all the debugging tools that you're familiar with, and there's a way to do that so let's open up the your targets file. There you go. And we can add in another option up here. And we're going to say error equals workspace. I think it's workspace. Sure, it's not plural. Yep. So error equals workspace. And what this is going to do is every time it encounters an error, whichever target through that error, it's going to generate essentially a virtual environment that you can step into. And it's going to have, at the time of the error, all of the objects that were loaded in, everything is the entire state at the error. You're going to be able to jump in and explore that in an interactive session. So you can start, seeing like maybe the data is the wrong dimension. Maybe, you passed in a character variable and it should have been a numeric. You can figure out those kind of things just by playing around. So exercise for this module is to basically get back to where we were last module and get it running smoothly again. So you can either open up that R functions R or just run that line to open up the functions. Has anyone unraveled this classic error?
So I saw that if the k is greater than 2, it throws the error.
Yep.
And
yeah,
so
exactly
it should be less than 2, right?
Yep, exactly. So I kind of, I artificially created the error here because I didn't want it to rely too heavily on anyone's actual experience or knowledge of R. But yeah, that's exactly it.
And then the next thing I get is an error on the group by for the plot.
Ah, interesting. Let me see.
Yeah, and so that one I'm not really sure where to. Do I go into the meta and look at my KM object that it's stored from the last make?
Yeah, so there's a couple of ways you can do that with. In this case, I think that would work really well. So if so here's that error. I'm basically forcing it to throw an error that I just kind of confusingly called that common error that you've got on your first day or two of using R. But yeah, if we get rid of that and so if this runs smoothly, but this is throwing an error, what you could do is just open up a session, load this in, and then just start playing around with this code here. And for this case, that's definitely going to work. That's probably honestly the fastest way to figure it out.
Great. I know what this error is. It's saying that it says the error that it gave me is no applicable method for group by applied to object of class null, and that just means that it can't find one of those two. One of those two arguments in the group by statement. So it would just have to look if pred cluster isn't there or species isn't there, or there's something weird with those names, and then it probably will run.
Yep. I think it was the if statement needed to go before. If you kept the if statement, if you moved it before you did the k-means, it works.
Oh, the plot.
So in the run KM, I think the problem's still in run KM. If you leave the if statement there and change to k less than 2, I was getting the same error as you. I think that you had to move the if statement to above the rest of the work, like do an if, else if.
Okay, gotcha. Yeah.
So I think that run KM wasn't being made properly. And
so
gotcha.
Okay. So deleting the if statement would have been the other option.
Yeah, I just commented it out and it worked, but when I left it in you did.
Oh, interesting.
Okay. Interesting. Yeah, that is kind of interesting behavior. Yeah, when I was developing this, I did exactly the same thing. I just deleted it or commented it out. So it's like maybe I missed. Hopefully I didn't change something here, and the whole ggplot code is off. Okay, cool.
All right. Well, if I save everything and rerun it, it'll work then.
The reason why is if you leave that if, it's the final statement in the function that gets returned, and so it's not returned.
Okay.
Yep. No, that makes sense.
Great.
Cool. Yeah, and you'll notice that when you do make it, it's not. It's hard to tell because it runs so quickly, but those steps that did work, the raw file data cleaning, PCA, all of that, none of that gets rerun. So it's only starting at the error, everything downstream.
Yeah. Okay. It's clear now. So.
Oh, so I had a question though with the tar workspace where you reload the workspace, tar workspace, with KM, and so I see it brings in all the. What's it actually doing? I see all the environment variables. Is it actually restoring a session? I'm not sure what the right terminology is.
Yeah, so it's I didn't actually demo that, so I've got it set up in the targets there. I'm gonna bring that error back in. Let's make it, and it gets an error. Yeah, so what you can do then, I think if I'm remembering right, it puts it in here. So yeah, within your data store, you get another object called another folder called workspaces, and it creates it there. So yeah, sorry, I realized I didn't go into as much detail on this as I should have. And you can also call tar workspaces, and that'll just print out all the ones that you've got, or all the ones that have been created. And then the singular tar workspace, you can just put in any of the workspaces as an argument. And then you'll notice up here, a bunch of things just got popped into my environment that weren't there before. So I've got, the PCA, which, so remember, this takes in the output from PCA. So now I can play around with that. And I've got all of the functions that were available. So I can actually, call run. I can start out doing like run km PCA k equals 3. And I get that same error. And then I can, look at the function. I can, I can debug it. So one good way to do is say, okay, like, it's definitely in that function. Let's turn the debugger on. And cool, now I'm in an interactive debugging session where I can start, going line by line. I can say like, okay, so the first 2 steps are running fine. I can kind of step through it, and then up there, and you can figure out, what line is actually throwing there. And that's really helpful if you've got, a much more complicated thing, or maybe it's, here it's, the function really is just at the level of my defined function, but maybe, you're running some algorithm, and that algorithm calls, a bunch of internal functions that call, something from another package, and it might be like, 20 levels down in the call stack where that error is actually happening. So this will allow you to kind of drill into that. But yeah, exactly. It basically loads the environment at the time of the crash into your global environment. Capital Q to get out of that. Cool. Any other questions on debugging? Again, there's a lot of different things, kind of more advanced things you can do with it, but that's really the core is, being able to turn on workspaces. Another thing that I'll mention too is, I forget the exact, it's not error, I think it's just workspace equals, you can pass in a list and create workspaces even if something doesn't error. And that's going to be really useful too. Like maybe you want to just check and see, you're kind of curious how something happened, or you want to look at some intermediate result. I think there's an option to turn it on for default for all targets, which is, can get really unwieldy if you've got a really complex pipeline. You probably don't want to keep all those intermediate things, but you can also, if there's just like one thing in particular that you want to be able to just look at really quickly, you can turn that on like at a per target level. Cool. Let's go ahead and move on to the last module then. So do the same, clear out the environment and restart. And just realize that should be our markdown for the title of that. Yeah, so right now, I mean, this has been kind of a whirlwind tour through all of it, and you can go so much deeper on any of the topics that I've talked about, but kind of the one, I would say, like glaring hole in the whole general analysis framework is, how do you incorporate your output in the pipeline? This is great, you've run your entire pipeline, but as it stands, you'd have to somehow like create another markdown, get all of the objects created by target in there, and work with it. So I'm going to talk now, spend the rest of the workshop talking about how to incorporate our markdown into your pipeline. It's same basic idea, but there's a few additional things that you have to do to incorporate that. So again, let's load the library. We're going to start with a fresh data store and copy over the new set of targets and functions. So yeah, within our markdown file, you go use those. And we're back to the second module, looking at tar read and tar load. You use those to bring in your data. So then typically you probably have your whole like analytic pipeline, and then in your Markdown, you somewhere you like read in a CSV file or read in an R data file or something like that that brings your results in, and then you know make your table and show your plots and all of that. That in a targets workflow, essentially read CSV, read table, read whatever gets replaced by tar read. Generally, you're probably not going to use tar load within Markdown because that's just calling in file paths or paths to files, but tar read will do all that. And then this has like a kind of cool benefit of I'm sure you probably, if you've worked much with R Markdown, you've probably been in a situation where you do your whole analysis and you get it all run, and then you like realize something, you're like, oh, I want to tweak that one thing, and then you kind of end up doing some analysis in the Markdown document, and then kind of sometimes that can grow a bit and get more complicated, and pretty soon your analysis kind of is spread across the two things. This really encourages you to do all the analysis in the scripts, in the targets, and then the resulting Markdown should be really lightweight. It's pulling in things that are just ready to be, like we've already created a plot, so we're not even going to put any ggplot code in the Markdown. We've already, created our data set. If you're say like using GT summary or something like that to create a table, you can do all of that in its own target. And when it comes time to compiling the report itself will render really quickly. So if you need to change just one aspect of it, building up the pipe or redoing the report isn't actually redoing your analysis. So as far as putting it into the pipeline, Targets doesn't directly support it, but there's this companion package called target types, which is basically just like common. There is a way to do it, and if you look somewhere in the documentation on this, it shows an example of how to do it without touching the target types package, and it just gets really messy because of how you have to you basically have to your function or your command within the target has to be a call to like R Markdown render, and there's all these arguments need to get passed around. It's really a mess. So they basically, for complicated things like that, they've created new tar functions that are available in the target types package to do things like render an R Markdown. So here are the two changes that you need to make. First, you need to put in library target types at the top of your file. So now instead of just loading in targets, you're also loading in a second package. And then introducing a new function here. We've only used tar target. Instead of that, you're going to use tar render. And that's going to give, again, you put in whatever report name you want to give it. And then you give it a file path to the Markdown file. So use that instead of tar target. So within the folder /R Markdown, I've created a simple Markdown that you can incorporate into your pipeline. So the first exercise, what you just open up, use tar editor, open up directly, and change your targets file, check the status, kind of get into that workflow of seeing what's outdated, seeing what still needs to, what's already run, and then incorporate that Markdown in here. And I'd encourage you too to get in the habit of doing things like checking tar outdated, checking tar glimpse or Tarviz Network over tar glimpse, but doing those checks rather than just making a bunch of changes. And it's easy just to hit tar make and hope for the best, but it can definitely cause you to run a lot of things that maybe you're not ready, or you realize that something changed that you weren't anticipating. That's always a good habit to, before you commit to running everything, take a look and make sure that it's in a good shape for, it's in the status that you expect.
Just curious, for what I'm adding it onto the pipeline is a tar render function at the bottom of my list of tar target functions, or am I adding another target that is the rendered output? And I use the render on as a function.
Yep. So this is basically going to replace tar target.
Okay. Okay, great. Because I think I was like, I'm adding another step here by creating another target. What? Maybe I should check. Okay.
Totally. Yeah. No. Exactly. It's the same sort of, when you have this whole list of targets built up. It's it's going to look the same. It's like tar something with the name of it, and then what it's going to do with the file path. Just in this case, you're changing it from target to render.
Okay. Thanks.
Yep. How's it going for everyone else? Yeah, so so use tar render instead. Do reports. We got to give it the full file path to that report. And yep. See here, I'm getting an error that says couldn't find function tar render. That's because I forgot to put in. Archetypes. And of course, we start out fresh, so everything's outdated. But if I zoom in on this, I've got that new report, which just depends on plot. Let's go ahead and make that. And everything built successfully. Everything's up to date. And now I've generated the report. Open that up. And we've got our report on the penguins. You can see we've got everything here, the plot. And as a fake sensitivity analysis, you can try now incorporating, add a couple more targets, and try rerun your k-means analysis with k equals 4, and then include a plot. Obviously this is a little silly because we already know that there are 3 species, but it works to illustrate the point. We'll do an informal quiz too. If I change this around and say, do this, some commas. So I just changed the order. Anyone have any guesses on what's going to happen? So here I'm defining my raw data, then I'm calling, then the report, then raw data, and so on.
Well, you're not going to have the objects that the Markdown document calls, right?
Let's try.
Or will it?
Yes. Let's go tar. That's actually all good. And if I go tar make, skips everything because everything's up to date. So it's kind of might seem a bit weird at first because it feels like you're specifying like do this, then this, then this, then this. But it's easy to forget that this is actually just a list. And actually, it doesn't matter what order it's in. It's not executing the elements of that list sequentially. It's got a bit more smarter logic in there. and it's actually parsing all of your files, all of your code to detect those dependencies. So you notice, like, even though I put render as the second one here, when I hit tar make, it still puts the report way down at the bottom because it's at the end of the pipeline. So that's kind of cool. So it's, I mean, I wouldn't recommend doing it like that. So that's just going to get confusing to read. But, you know, there are times where you'll have a more complicated pipeline, things will branch and it's not clear what comes, you know, first. So it's good to know that it really doesn't matter what order you put this in. And it can be helpful to, you know, one strategy could be, you could create a bunch of different lists. You know, you could do ETL is that part. Targets is that part. You could do something like this. I think that's correct with commas. And the only requirements from targets is that it just ends in a list. So then I'm just going to want to combine like that.
You got one last extra comma after tar render.
Oh, yep, thanks. You know, so if I do that, I'm curious about. Oh, it's kind of interesting that that picks those elements up as objects that it's tracking now. But otherwise, you can see it keeps the pipeline up to date. So that is one way. If you start, you're like, oh, God, these targets are getting out of control and they're just everywhere. It doesn't all have to be in one list. You know, ultimately, what you're doing is just creating a list. You know, it's just an unnamed list at the end, which means that, you know, we were talking about like different ways of like doing hyperparameters or something. There are like more kind of, you know, maybe more sophisticated ways of doing it with this branching that I've talked about. But one way that you could do it is you could actually just build up a list of expressions, you know, using, you know, either per or lapply or something like that. And essentially build up a list, you know, iterate over, you know, k equals 1 through 10 or something. Build up that list programmatically and then insert it into your list at the beginning. You can kind of, you know, think outside of the box a little bit and how you construct that list. Of course, the more things you do like that, then, you know, there's more chances for an error to crop up or to, it might be a little more opaque. But if you are doing something like really repetitive, that can be a good way of doing it.
Do the per mapping functions play well with this? Like, one of the things I'm going to end up doing pretty soon is a benchmarking study where I've got data from statewide, and then I want to look, and each and it's data from hospitals around the state, and I want to go in after I get the statewide data and do benchmarking for each hospital on some specific metrics. But I'm going to want to give each hospital their own individual report, and so I want to make a template for that and iterate over the data. But once I pull in the statewide data, I've already got, I have to make subsets of the hospital stuff. So
right,
it seems like there's a bunch of ways to iterate on this and not have to make everything for each hospital, right?
Absolutely. Yeah, there's a few different ways you could go about doing that. Kind of, you could, so I guess to answer your first question about whether per plays nicely with it, it does kind of on either ends. And what I mean by either end is within the actual like pipeline itself and in the construction of the pipeline. So if you were to say like build up this list using per, you would have to, you know, put in library per here. Because this is, you know, the tar option set packages is basically the list of packages that it's going to load when it's executing in that isolated environment.
Yeah.
But if you're anything that you're using here to build up that
in
pipeline,
the pipeline, yeah.
Exactly. And I mean, and you could do, I mean, this is just, R here, you could create a plot if you wanted to. It would not, I don't know why you would do
but
that.
I mean,
but
that's why we had
you
to
would need
bring
to load
in
that code there.
Right.
Yep.
That's why we had to bring in the archetypes package, was for that tar render function.
Exactly, because I'm calling tar render here, but I don't need to call it here because
we're not using it
with tar render inside of the environment. Your code, your analysis is not using archetypes. That's just kind of a helper to set up the package. Of course, if you were doing something in your pipeline that somehow involves archetypes, you'd want to put that in there. But so you really just need to think about like, what is your pipeline actually doing? And then in terms of your problem, that's like really interesting. I think perfectly set up for doing this kind of thing. Like you're doing something intensive up front, and then you want to do something like really repetitive without having to rerun that additional, that upfront, without incurring that upfront cost every time. So I think branching would be one way. There's kind of a method called static branching, in which you kind of define all of those branches up front. And then there's another one called dynamic branching, which based on like maybe like here in this case, you probably know how many hospitals there are. So let's just say you didn't know that, or you were going to run it on, give this code to someone in every state, and they were going to run it. Of course, there's different number of hospitals in every state. You could essentially, think of it as like a parameter, that you create branches, all these different targets based on some output of a previous target. So you could have some early step that's just saying, okay, like how many unique hospitals are there? And then create a new branch for each one of those and apply, this report, generate this report in which it subsets the data that you've only read in or only, analyzed once, only cleaned once. So that sounds like a perfect case for it.
Yeah, very cool.
Maybe I'll go through. Get back to a better way of doing this. I'll go through the that kind of fake sensitivity analysis just to show you what a more complicated pipeline might look like. Let's reset that. All right, cool. So we've got everything built back up, the report there. Let's say, we want to, and again, we're gonna, instead of doing this like grammatically or branching, let's just create, we're gonna run the analysis on with k equals 4. So let's just create a new target, call it k4. We're gonna have to give our plot a new name, so I'm gonna call that plot4, and that's going to run our plotting function, so we don't need to rewrite any of that code again. We're just using that same, we're going to generate exactly the same plot, just on a different data set. So we're going to run that on KM4. And that's good. You can see it's starting to look a little more interesting. Up until now, it's kind of been a pretty linear, this, then this, then this, then this. So now we've still got our linear pipeline here. If you're following the circles, the stems, we take in our raw data, we go in, clean it, ECA. But at that point, now we've got an actual like true branch in our pipeline where, we're creating these new targets. anytime PCA changes, it's going to kick off everything downstream. But right now, we're not going to redo that original k-means with k equals 3. We're only going to rerun those two. And, like I said earlier, it's a good habit to get into, looking at your network graph before you run it. Because in this case, you can see that plot 4 is not connected to the report. So if I went ahead and did tar make, network, again, everything ran. But if I go back to the report, you can see it's still just got that one plot. We didn't actually connect it and bring it into the markdown yet. So to change that, we've actually got to go into our markdown. We want the report to change. So now in the sensitivity analysis, create a new chunk. And all we need to do is just read in that plot 4 object. Save it. And now you can see again, all of our analysis is already run. So at this point, we're not saying like, oh, crap, forgot to incorporate it into the report, have to run it again. It's already ran. You just, the report is lightweight. Now we can compile it. And now we've got, our new plot with 4 different categories in the for our clusters. Cool. Any other questions on that or anything that we've covered so far?
There was another question in the chat about parameters in a file, and I'm actually curious about that as well.
Okay, cool.
If, like, say, if you had a parameterized or a markdown document or something.
Oh, yes, exactly. So, I guess there are kind of 2 ways to interpret that question. One is kind of like going back to what we talked about, like hyperparameters and wanting to run the same thing over a bunch of different values of a parameter, kind of like with k. So there's that, and then there's like parameterized markdown. You absolutely can. I'm trying to remember. Might actually just pull up the documentation to refresh myself. I believe within the markdown, so that you would typically have your params spelled out here. You would essentially do that in the same way, but I believe just read them directly in there, because within the parameter space, you can put in any kind of R code into that.
I was going to ask if you would just want to break those parameter sets out, like say in using my example, if I had one R markdown that was my template for those hospital reports, individual hospital reports, I could run that on each hospital by having the hospital name as one of the parameters in there and have the set of those saved as its own target or its own source.
Right. And that probably would.
I mean, unless I wanted to just feed that list directly in there, but I'd have to get it ahead of time.
Right. Yes, I guess it kind of depends on whether it's known ahead of time or you're doing it, kind of figuring it out on the fly. So there is a chapter just on parameterized R markdown in the guide. So I would recommend looking over that. But it's essentially, and I think this tar render rep is like another function basically built within the tar types package, where you specify your parameters here. I think probably my first approach to this would be to create another target that builds up those parameters. So say it's like unique hospitals, and then create a function that basically looks those in and selects the appropriate one. Because right here, this bit here, that's just R code. So you can write a function for that. You can call it on a previous target, and think about how to construct it, so it's passing all of that correctly. yeah, it's interesting. I've worked with parameterized Markdown a lot before, and I've worked with targets package, but I've actually never put in a parameterized Markdown into a targets pipeline.
Yeah, it's for us. It's probably it's more like a standardized Flex dashboard. We're probably going to do this for both the benchmarking for performance measures, but also we're probably going to be doing data quality reports for each hospital as well. And so we've got a Flex dashboard that is the template for those data quality measures, and then still have to figure out a way that we're going to be sharing all those out too. So
right. Yeah, that's cool. How many hospitals are you looking at?
Just for the trauma system, which is what I work on, it's 43.
Cool. Yeah, so definitely a number where you wouldn't want to be doing all of that.
I don't want to do it by hand. Yeah. Any of it. As much as I can automate away, I'm doing.
Absolutely. Automate it and make it easy to, again, like someone decides that one metric should be done slightly differently.
Well, actually, the data standard updates every year.
Okay, so it's coming, then it's, everything can be get it set up and everything can be rerun.
Yeah, so we have to plan to update it every year because of the data standard changing every year. So
cool.
It's not really a planned obsolescence, but something like that.
Yeah, gotcha. Cool. Yeah, that concludes all the material that I had to go through. I think there was a couple maybe exercises back in that second module that I didn't think we'd have enough time to fully go through, but we want to play around for a little bit more. It's just like creating more targets and getting them to interact with each other. But yeah, kind of as a quick wrap up. I've talked again, I pretty much already covered this on branching. If you're looking to really use this for like more complicated workflows, I think branching is pretty essential. I remember I kind of dived into it, I think a little too early, and I was just like, this doesn't make sense. So like, I think really getting that core understanding of the targets file, how to specify a target, getting that just basic workflow of, you're coding, you're doing your analysis, you're generating your visualizations, all that, but also, stopping and okay, check the network, see what's outdated, run it, figuring out how to debug it, getting that kind of core workflow, I think is the biggest learning curve. And once you've got a good grasp on that, then the branching, I think, makes more sense. It's just essentially automating kind of what we just did in that last example with like running, 2 different values of K. So yeah, and like I said, there's 2 kinds of static, dynamic. Both have their places, their purpose. This is a cool one that I actually it just came out within the last month or so, and it's only on the development branch. So I haven't really had a chance to play around with it much. But you can actually there's like kind of a whole new like target markdowns, and this is different than incorporating markdown into your target pipeline. This is actually setting up like instead of having like a targets file and an R file, doing everything within an R markdown document, which has some advantages. One, a lot of analysts kind of approach analysis that way. That's good. It has a lot of pros to it. You're tying together your code and your documentation. Essentially, it's forcing you to explain what you're doing at every step of the analysis. You can go back and look at your code, look at the results, look at your comments and your documentation all together. But you can actually now, at least in the development version, actually build all of this up within an R markdown file. So I think that's kind of cool. And also just like this is there was a Drake, which has been around for a little while. We kind of like figured out some bugs in that, put it in, kind of revamped it into a new version, but there's still a lot of active development on this. There's also just a lot of more advanced topics that are a bit more specific to, say if you're working in a cloud environment, you need to get data from different sources like that, or working with databases, doing things like parallel computing if you're working like a high performance computing cluster. That's the whole nature of especially branching is like very inherently parallel. So there's a lot of functionality that's built into to take advantage of that, and kind of doing that natively so that you're still just thinking about you're still doing the same thing, breaking your workflow down into functions, arranging those functions together in a way that makes sense, and then kind of letting the targets package keep track of dependencies and figure out what needs to be run and what doesn't. But yeah, we finished up a little bit early.
There's a couple more questions in the chat.
Oh, cool. Yeah, I keep moving the chat out of my window so that I can see my screen. So thanks for bringing those up. Let's see, any advice when to integrate targets into a project? That's a really good question, because one extreme would just be say like always use it, but of course that's a lot of overhead that you probably don't need. And sometimes someone like might send you a data set and say like, hey, I got have a couple of simple questions, or just like run this for me, and then of course they come back with more questions, and pretty soon it turns into a project. So for that first look, you're probably not going to set up a whole pipeline and everything. I would say one thing that I think just working with targets more, and honestly just like developing programming skills, you'll start to like think of things in terms of functions, and instead of just like writing something to solve the problem at hand, we'll kind of think, okay, like I've worked with this person before, they're probably going to come back with more questions. How can I spend an extra couple of minutes instead of just getting the answer, writing it into a function? And then at least you've got to start there. You're not, I have translated projects from, totally from, just messy scripts everywhere into targets workflows. And that can be a bit challenging. So if you just kind of start adopting that function mentality, that'll put you one step closer. In terms of like when to integrate it, like if you know from the start that it's going to be this big complicated project, you're probably going to be rerunning things, changing things, I would say just right up front, make that commitment, and then you can it'll evolve and change as the project goes. But otherwise, just think about like, how much time are you spending rerunning things? If you're constantly, with whatever setup that you've got, maybe it works at first, but then pretty soon you're like, you're sitting there and waiting for your code to run, and then you realize that you need to go back and change something, and then you're like sitting waiting for like unnecessary things to run again, and it's starting to eat into your time, or you're forcing you to multitask when you don't want to. I think that's kind of the stage when I would start thinking like, okay, like how can I streamline this a bit and organizing it. And then like I said, yeah, if you've already written your code kind of thinking in terms of functions, then refactoring it hopefully would be a bit less painful. Question on looping on the pipeline flow. So I'm not sure if I fully understand the question. So you're talking about like doing like a for loop, like within the targets file?
Yeah, exactly. I was thinking if I've got a process that's down pat for a given data set or example, or a particular parameter set that I then want to change or stress, and I just want to go around a section of it. And I wasn't sure if that was what you're referring to in branching earlier. And I just wondered what the next steps were. I appreciate that might be more complicated, but I just wanted to know where to look.
Yeah, no, that's a good question. I think get all of the chat windows and everything back out of my screen. I think we're still in the state where this is up. Yeah, so I think so generally when you talk about a for loop, you're talking about doing a repetitive thing, doing something repetitive. You're doing the same thing over and over again with just like changing one parameter or something like that. And that's essentially what we did here. Of course, if this were not in a targets workflow, we might have done something like.
Yeah, I wasn't sure about sort of just like you did the k-means by just doing an extra step. And I wasn't sure, well, if I had 20 extra steps or parameters, there's a trade-off between a branch and just looping around that. So that's why I was asking.
Yep, exactly. That's exactly what branching does.
Right.
Yeah. So in this case, maybe make an analogy. We could do like run km. Yeah. Data k equals 1. You see this in a lot of beginner scripts, right?
Yeah.
And then you learn a little bit more about programming. And you're like, oh, I can just do for like I and 1 through 4. Run km data k equals I. So that's kind of the next level of that. Within the analogy between these two, or analogy is kind of like these two are alike in the way that I did, the way that I built up k-means, I'm just like replicating it. That's kind of like that really naive way of doing it that might work for a bit, but it doesn't really scale very well. The for loop equivalent is branching, essentially. And yeah, you specify, also remember way back in the beginning, this tar manifest function that we didn't really look at too much. We've got this pattern here. The pattern is kind of an argument that's used when you're building up these targets to specify how you want to branch. So you could essentially build up a pattern that would branch up, branch over, multiple values of, a set value, certain like range of k that you want, or maybe it's a parameter that's dependent on something that happened earlier. So you want to only look at values of k through some limit determined by something that happened earlier in your analysis. Then you could specify that.
Okay, so I should look at pattern then if to try and see what the next steps are.
Exactly,
right? Yeah. Right. Okay.
And I would start here in these 2 chapters on dynamic and static branching. And I think really working through an example is helpful too. So yeah, that, and I'll make these slides available as well too. But this workshop here, and I think he's got a couple like similar workshops on his GitHub. Kind of working through that branching workshop is really helpful too, and you can actually like, see it in practice. I found it to be the easiest way to grasp that.
Okay, that's really good, because the example we've talked about with the hospitals is you might want to iterate over a number of hospitals or a number of parameter sets, and I thought that's really powerful with this workflow. So. Yeah,
absolutely, and I think looking around it, if it's on the author's Twitter, or I've seen various examples of just like crazy complicated workflows. Here we've got it's pretty minimal, and already it's getting a little messy with all these arrows and stuff. But it's kind of cool seeing the ones that are built up with like dozens or hundreds of different targets that are all connected, and this Viz network package does a really good job at kind of automatically organizing that and detecting the relationships and kind of presenting it in a meaningful way too, so it's not just a pile of spaghetti.
It reminds me of the React logs from Shiny.
And very similar,
but yeah, mine were messier than this.
Yeah, for sure. Yeah, it's honestly, I think that's kind of like a make or break feature of this package. Like I think if you didn't have a way of just quickly visualizing that, it would be a lot more challenging. Another cool thing too, and I think it's tar progress. There's another, I'm blanking on the name of the function now, tar watch. Yeah, here we go. So say you did have like a pipeline that took, the entire data run, and you just kind of wanted to monitor it. There's actually, instead, it's kind of like Tarviz Network, but it actually launches a Shiny app in the background. You can just like go back to and check, and it'll actually say like which part of the pipeline it's executing, what's already been done. So you don't have to sit there and like take up your console with the the little checklist that says like what's being skipped and what's being run. I don't think it would. Try running this. I have a feeling that this is. Yeah, I forget. I'm on RStudio Cloud. I don't have Shiny installed. But generally, you would need a little bit more. Maybe putting in like a sweep command or something to like force one of these functions to like wait a minute or so. Would be a better demo of that. But that's also useful for and kind of a cool feature. Cool. Yeah, and thanks, Andy, for linking that too. All right, cool. Well, happy to stick around for a few more minutes if there are any more questions or want to chat about anything. But yeah, thanks everyone for coming. Hope you found it useful, and yeah, hopefully this gives you a good jump start that you need to start building targets into your workflows and saving you some time.
Yeah, it's making me realize how much more I need to work on my functions, because I do a lot of just the basics of it, but then I add a whole lot of stuff when I'm like building out a bunch of different tables and things like that. So yeah, I think we'll probably end up having to build packages for the functions, and then a workflow separate that's using like the sets of packages, so that because it's going to be too much to try to maintain all the functions and within the just a pipeline file without the package management like features and stuff, especially when things like the data set is updated annually, and I'm going to have to go in and change things like specific field names and stuff like that. So
yeah, and I think
I can definitely see those two workflows being right in tandem.
Yeah, for sure. And I think once your functions get they're complicated enough, then you probably start wrapping that all up into your own internal package and simplifying the the functions that you're calling within targets. And then there's also kind of two not necessarily competing school of thought, but two different approaches that you can take for reproducibility. And that's like the package oriented analysis. And I'm thinking of this more in terms of like, say, like a scientific analysis, like a report that you're generating, you're analyzing a data set versus something that's going to be like run regularly or automated or like, QC or anything like that. But, there's like the kind of philosophy of like put everything into a package and do your analysis as a package, or you can also do it in like a workflow tool like this. So from a reproducibility standpoint, both are good. But then the package isn't going to save you anything, from like a computational efficiency point of view. You're still gonna have to like take those functions that you made, and even if you have like a master function in there, you're gonna have to like rerun it all the time. But yeah, kind of the hybrid that you suggested there, just putting it all into a package and then incorporating that into the workflow is a really good balance. And then,
and we also
cool
use the functions in different different reporting processes too. So packages give us a way to share more of the like modular pieces. But I definitely want to have something like this where I can just maintain the pipeline, right? And if I want to work on functions, I'll go over here and work on functions, because otherwise I'm kind of toggling too much between the tasks. So
And then, yeah, just like separating it out, isolating it. And then, yeah, you're not worried about like, you know, the effects of like changing one thing impacting something else. If you're trying to change your workflow and all of a sudden that's breaking your functions or vice versa, you can just
right.
they exist in separate places. Yeah, no, it's pretty cool how I think that I don't think it was an intention of the package, but it's definitely a side effect that it's a good educational tool, and that like using it teaches you to be a better programmer. And I, you know, most packages, it's just like, you know, they exist to serve an endpoint of, you know, making cool plots or implementing a model or something like that. This is like, oh, like if I actually use this, like I'm going to be a better programmer. It's going to force me to think about things better in a better way.
Yeah, very cool. Thanks, Mike. This has been really awesome.
Cool. Absolutely. Yeah. Thanks, everyone. Thanks for all the questions, and you enjoy the rest of the conference.